Good afternoon. My name is Ansgar Grunseid, and today we're going to go on a little adventure and journey into the world of Saturn. Now, what is Saturn? Saturn is a new content delivery network for IPFS and Filecoin. Let's get started. So, every great product starts with a problem, starts with an opportunity. And Saturn began with this opportunity. IPFS can be faster. I'm sure you've all retrieved content from IPFS and gone and made yourself a cup of coffee and come back and still waited a little bit. That is the core problem that Saturn is going to solve. So what we've seen here with Filecoin is Filecoin's assembled an absolutely massive storage network, but leaves a lot to be desired as far as retrievals go. So we've seen Filecoin assemble 17 exabytes of storage, 300 petabytes stored, but the core problem is, where's Web3 YouTube? Where's YouTube built on top of Filecoin? No Web2 scale has been achieved yet on top of IPFS and Filecoin specifically, and why is that? Well, the real reason, one of the core pieces that's missing, is content delivery. To be able to build an app like YouTube, you need to have fast, reliable content delivery. You can store a file on Filecoin, that works beautifully. But now imagine you store video, like a YouTube video on Filecoin, and that video is going to be segmented across IPFS, stored on 6 to 10 storage providers in the Filecoin network. But now imagine that video goes viral, and you have hundreds of thousands of people all around the world trying to watch that video. It can't keep up. So this is where Saturn comes in. Oh, and there's one other piece here, which is that we've already seen how much demand there is for faster IPFS retrievals. You can just look at the myriad of variegated content that's stored in IPFS every day through gateways like NFT storage, Web3 storage, et cetera. And all this content is available on IPFS and available at the IPFS gateway, but apps are waiting, they're chomping at the bit to be able to access this data quickly. So this is the huge opportunity that we see and realized. But also, like every great product comes about because something changed. The world is different in some way, and you seize on that and take advantage of that and build something you couldn't build before. The big change that Saturn has realized and embraced is that of cryptographic incentives. So crypto incentives are rewiring the internet. We see this all over the world of Web3, where centralized proprietary services are being replaced by decentralized open ones. Filecoin is a great example of this, where Filecoin is disrupting and replacing many of the use cases of Amazon Glacier, S3, et cetera. And so we at Saturn see this windfall, see this changing world, and have leaned into this. Fundamentally, Saturn is a crypto-incentivized content delivery network, one of the world's first. And these crypto incentives are what's used to grow and scale the network, and we'll get into that in a second with some of our goals. But the other key piece of Saturn is that, like all these cryptographic networks, they're trustless and they're open source. And we'll get into some of the technical details of how we can build a content delivery network in a world that's trustless and permissionless. And lastly, like all these other projects in terms of being open source, Saturn 2 is open source. All our work is on GitHub. We encourage all of you to go take a look through our code, submit bug requests, and get involved with the community, and we'll get there later too. So, we've gone through the problem, we've gone through what's changed, our little insight with crypto incentives. What is our solution? What's the product we're going to build? And that product is a crypto-incentivized content delivery network. So, if we juxtapose content delivery networks of the past, we talk about Akamai, Amazon CloudFront, Cloudflare, et cetera, what these networks look like is centrally managed, top-down, constructed global networks. That means there's a room somewhere where a bunch of Amazon execs get together and they say, where are we going to build our next data center? There's a small team of people that decides where the network grows and how the network grows. Saturn fights with an unfair advantage on the other side. What we have built is a marketplace for content delivery capacity, like a marketplace for bandwidth. So we have no central organization or central team that decides where to build infrastructure and where to grow infrastructure. Instead, we've built marketplace primitives into the network itself, where anyone all around the world can just spin up a server, install Saturn software, and add a node to the network, share content with the network, and be remunerated in Filecoin in return. They don't have to ask my permission, they don't have to ask any of your permissions, they can just go do it. And that's a fundamental difference between prior content delivery networks and our unfair advantage. And we're going to lean into this to scale to millions of nodes globally. Not just tens of nodes, hundreds of nodes, thousands of nodes, millions of nodes. And we'll get into kind of the way Saturn's network is orchestrated with the different players and different pieces. There are different tiers. Just like in your computer, there's multiple tiers of cache, L1 cache, L2 cache, L3 cache, et cetera. There are different tiers of Saturn's cache as well. But the core piece here to take away is that Saturn leans into these crypto incentives to build a different kind of network to grow faster and grow larger. So what are the goals? The first and primary goal is accelerate IPFS content. Again, we'll go through a neat demo here shortly, but when you retrieve content on the IPFS network, oftentimes it's slow. And then there's the IPFS gateway as well, and the IPFS gateway leaves some room for improvement as well. So our primary goal is to accelerate IPFS content. But our larger, bigger goal is build the world's best, fastest, lowest cost CDN, period, in human history. We're singularly focused on that goal and how to get there. Now, another key piece of Saturn is to include everyone, be inclusive. And what this means is we want to unite humanity's heterogeneous hardware. Everything from big beefy servers and data centers to laptops like the one I have in front of you, the one I have in front of me and the one you have in front of you, to phones and browsers and everything in between. Imagine if we had a little magical thread that we could weave into every device on the internet so they're all sharing, communicating, like built on IPFS. That is the world we're building towards. And why? Why are we building towards that world? We fundamentally want to advance IPFS and advance Web3 adoption. We want to hasten the YouTubes of Web3. We want to hasten all the apps that are sitting there waiting to be built, but can't because retrievals aren't fast enough. And the last piece, our last core goal of Saturn is to democratize earnings. So what does that mean? What that means is right now, if you go and buy content delivery from a content delivery network like Akamai or Cloudflare or AWS, that money goes from your pocket into Jeff Bezos' pocket. And what we want to do is take a very clever little knife and cut that money up and redistribute it into everyone who contributed to the network. So what does that mean? What does that mean when anyone can spin up a node and earn Filecoin in return? What that means is we don't have these centralized powers and content delivery isn't centralized. So we want to democratize earnings. So how? How are we going to do this? How are we going to achieve these goals? By building a crypto-incentivized content delivery network with these fundamental pieces. And we'll go into some of the technical details of these here in a second. So at a high level, the first piece is a retrieval client. What's a retrieval client? This is the piece of software that fetches content from the network. And we've done some very clever things here. One of the key pieces here is we built something called incremental verification. So imagine this. In a trustless world with a trustless content delivery network, you ask the network, please give me a picture of my favorite kitty. But how do you know that the content delivery, like the Saturn node operator, who we don't know who they are, you don't know who they are, they really just don't like cats. Instead, what they do is they want to send you their favorite puppy picture instead. So you request a SID of a kitty, but you get back a picture of a puppy. How do you know, without trusting the node, that they handed you the correct content you requested or the incorrect content you didn't? And so one of the things we've built is, in the browser, a piece of software that runs in what's known as a service worker. And what it does, it incrementally verifies a car file as it's retrieved from Saturn. So in your website, when you request a SID, like of the kitten picture, you send, you ask the network, please give me the content for this SID, and you start getting back a car file from the nearest kind of edge point of presence of Saturn. And what happens is, you requested the SID, so you have the root SID of the DAG of that file, and then as that DAG is streamed back from this trustless L1, this trustless node in Saturn's network, you can see, does this first block match the root SID of what I requested? And then all of the leaves under that SID, do they match, in the classic Merkle tree? And so you can incrementally verify the content you requested is the content you received without having to trust that party, whoever's running the node. And this is a huge key piece of what makes Saturn's tick and lets us let anyone around the world run a node without having to trust them. But what do these nodes look like? So Saturn's network right now is bifurcated into two buckets of nodes. The first node is what we call L1 nodes, or layer 1 nodes. And these are big, beefy servers and data centers. So we'll get to kind of the requirements later of what this looks like. But think about it, these are the machines that sit on the edge of the network, not on people's houses, but in data centers with large capacity to serve lots of users reliably. And when I say reliably, I mean they don't flicker up, they don't flicker down. These are like semi-permanent to very permanent parts of the network. And next up are L2 nodes. And again, if we go back to one of Saturn's goals is to unite humanity's hardware. L2 nodes run on desktops, laptops, phones, et cetera, and they run with software that you can download. So coming soon, you'll be able to download a piece of software called Station, which is an Electron desktop app, and embedded inside of Station is a little piece of software for Saturn. We call it the L2 or the level 2 of the network. And then running on your machine with your full permission, and you can pause it and stop it if you want, is a little cache and part of Saturn. And so if you can imagine, we'll go to the diagram here in a second, but if you can imagine, we're building a giant global scale kind of BitTorrent swarm of L2s that support L1s. So just like in your CPU cache, you have level 1 cache and level 2 cache, and you first check level 1 cache, and if the cache miss, you go to level 2. Same thing with Saturn. When you send a request to the network, you'll get routed to the nearest L1, big beefy server, and if there's a cache miss, then you'll fall back to this kind of swarm of L2s. And now how do we power this? How do we take that little magical thread and tie all this together? Well, there's two pieces here. One is called the orchestrator, and the orchestrator is a piece of software which, when a new node joins a network, says, okay, what is your capacity, how much storage capacity you have, how much network capacity you have, and where can we best fit you in the network? And the logs are another key piece, which is to pay people, because people are remunerated for their contributions to the network. We need to keep track of how much data was served. When you are running an L2 on your machine and you send an L1, let's say 10 gigabytes that month, you need to be remunerated for contributing 10 gigabytes to the network. And so we keep logs of all this. And fundamentally, in terms of the logs, you are earned Filecoin per retrieval. There's multiple metrics involved that calculate how much you earn, things like time to first byte, how quickly you were able to send content, how fast you were to upload that content, how available you are, did you go offline a lot, did you go down a lot, and then there's a last piece here which is kind of anti-fraud. So let's walk through what this kind of architecture looks like at a high level now with a diagram. So on your left, it's your left, if you look in the little blocks, that's like the retrieval client. So this might be a browser or an in-game app, or potentially even a desktop app in the future. Imagine Steam, for games, where you suck down content from Saturn. And then this big old red arrow, this is where you, as the client, discover the nearest L1 node. And again, L1 nodes are big, beefy servers and data centers. And right now, we're using DNS, because this is the protocol browsers speak, and we need to operate in the browser. But in the future, we'd like to expand these other kind of discovery protocols so that clients can find the nearest L1 node as quickly as possible, and then establish which is the actual fastest node without having to rely on a centralized service like DNS. And then here, around the L1 node, we can see kind of this BitTorrent-esque swarm of L2 nodes. So imagine this, for example, the L1 box being like a server in a data center in New York City. And then all the L2s are all the users running this Station, a little desktop app on their machine in the surrounding New York City boroughs, maybe New Jersey, maybe Connecticut, et cetera. And they're all in support of all the L1s nearby. And then in the background here, the very far to the right, we have the Filecoin storage providers. And this is kind of bedrock. So when someone uploads a file, makes it available on IPFS or stores it in Filecoin, that is where the content is stored, and Saturn sits in front as an accelerator of that content. And then off and up and to the right, we can kind of see the orchestrator, which again is kind of this software that's tying it all together and weaving it all together. And all these nodes submit logs, and these logs are processed to calculate payments and also to do anti-fraud. So now, let's run through a little demo. You've heard me talk for a while, show me the meat, So let's go here, and what I have, can you guys see this okay? Or should I blow this up? Let's see here. So what we're going to do here in this demo is we are going to benchmark in escalating performance, requesting a SID from the IPFS network via the IPFS client, to requesting this content from an IPFS gateway, to requesting content from Saturn. And we're going to benchmark the three. And so what you see before you are nodes that I'm about to SSH into around the world. In the upper left, we have Sydney, upper right, we have Taipei, bottom left, we have Toronto, and bottom right, we have Portland. So these are VMs running in those cities. Okay, so if we take a quick look at this command, what this command does is there's a local IPFS node running in this VM, or all four of these VMs. And this first little piece clears the cache, so we go to network. We're not going to fulfill this SID from cache. And then we are sending a curl request, or using curl to send a request to this local IPFS node to request this SID. And which is this SID? This is what the SID looks like. It's a little, well, you tell me what that is, but a little guy in a little box. So this is the SID. It's about a 6.5 megabyte video file. So here we go. Let's slam enter here. And we're going to see how quickly we can retrieve this file from the IPFS network around the world. So here we go, we see some progress. So bottom left Toronto finished first. It finished with a time to first byte of 1.2 seconds. So the first byte of that video was retrieved from IPFS in Toronto in 1.2 seconds. We see 1.2 seconds, 700 milliseconds, and Sydney is still cranking along, 2.7 seconds. So keep those numbers in mind. Okay, next up is the IPFS gateway. So now we're going to benchmark the IPFS gateway. So if you take a look, similar command, we're curling, and you see IPFS.io up there. We're downloading that SID from IPFS gateways around the world. So as you can see, Toronto finished really quickly again, 140 milliseconds, and the rest of them are sitting there spinning, trying to fetch this content. There we go, Portland, 2.3 seconds, and the first two are sitting there spinning. Let's move on. They're not fetching the content very quickly. So now, last but not least, Saturn. So if you take a look here, it's the same exact curl command, except instead of IPFS.io as the URL, it's strn.pl. That's Saturn's little production slug. And let's see. Boom. So there's Saturn live running right now. So again, to compare the performance here, we take a look. Sydney, 35 milliseconds, Taipei, 53, Toronto, under 20, Portland, 46. So these are live numbers from live Saturn network nodes running around the world, being orders of magnitude faster than the IPFS network and the IPFS gateway. And you can go verify this yourself. You can go spin up VMs in all these locations and start submitting requests to Saturn, and this is all live. But don't wait, there's more. Here we go. So I have even better news than what you just saw. We actually just launched Saturn 2 days ago. 2 days ago, Saturn went live. So what that means is, yes, all of you beautiful people sitting here in this room can go run a Saturn node right now. So what does that actually mean? Well, if an L1 node is what we launched, and so that means you can, if you have a server, go download Saturn, run Saturn, share bandwidth, accelerate IPFS content, and earn Filecoin in return. And now the requirements for an L1 node are relatively steep right now, 10 gigabits a second upload, more than a terabyte of SSD, and more than 32 gigabytes of RAM. We understand that kind of the 10 gigabits a second might be a bit steep to start. However, we want to start high and see where like the network demand is. You know, what we want to avoid is people adding nodes, let's say with a gigabit a second. So like, imagine you've been to your favorite Ferris wheel. You gotta be this tall to ride. What we want to avoid is setting that really low, and then a bunch of people get on the ride, they put the harness on, they get clicked in, and then halfway through the ride, like, sorry, you're not fast enough for the network, and have to kick you off while you're screaming through the air at 300 miles an hour. That's what we want to avoid. So these are the requirements. If you have a server that matches these requirements, I encourage you, go set up a Saturn L1. You can make between 0 and 600 Filecoin a month, $0 to $3,000 a month, and the more content you serve to the network, the more you earn. And our website is saturnstrn.network. So you can go take a look at that site later. So what does it mean to run an L1? What does the world look like when you run an L1? Well, first of all, you need to set up a Filecoin wallet. We got to pay you. So you can go to set up a wallet. It can be a shared wallet, Coinbase or Binance or whatnot, or you can run your own. And then you need a Linux server that can run Docker. And we have an Ansible recipe, so you can go, like the recipe, one line, boom, you're up and running. And here's what it looks like thereafter to run a node. So when your node comes online, what you can see is this is the dashboard of all the Saturn nodes. Can you guys see that? Let me blow it up a little bit. Unless you guys brought binoculars, let me blow that up. So this is the Saturn dashboard, and right now you can see all the Saturn nodes running around the world. And a lot of these were added in the past 48 hours with people piling in. And here you can see their DNS weight, their performance, their uptime, all these statistics about Saturn's growing decentralized network. And then when you're running a node, you also have access to a dashboard like this, where you can see your earnings, how many retrievals you served, the amount of bandwidth served, et cetera. So all the things you'd care about running a content delivery node. And the last piece here is when you're running a node, you'll get paid monthly. So during that month, you're contributing content, accelerating IPFS content, accruing earnings, submitting logs, and then you get paid in Filecoin at the end of the month for how much you've contributed to the network. So what does Saturn's roadmap look like? So what we did just 2 days ago again was we launched with the L1 nodes, and coming up are testing L2 nodes and how to integrate these desktop nodes into the network. And then what's next year, kind of our immediate priority for 2023, is to scale the L1 network. So right now we have about 90 to 100 nodes, and again that's up about 50, that's doubling the network size as of like 24 hours ago, something like that. But we want to achieve, again, the world's largest, fastest, cheapest CDN. And to put in perspective, Cloudflare has about 240 points of presence around the world. Amazon CloudFront has about 300. And we want to reach that and blow past that. Again, we want to lean into crypto incentives to get us way bigger, way faster than any other CDN in the past. So that's our priority for like the first quarter of 2023. And the other piece here is we want to achieve sub-second time to first byte globally for IPFS content worldwide. So whatever SID you want to request from IPFS, if you can request it from, like as we saw in the demo, from IPFS, from the IPFS gateway, or from Saturn, we want every single SID you request to be, like retrievable and under a second, with time to first byte under a second. And then one thing we look very much towards doing is working with the IPFS gateway team to figure out how we can help accelerate existing traffic to IPFS.io. That's something we're really excited about. And then moving on to quarter 2, 2023, we want to integrate L2 nodes. Again, these are the desktop nodes into the main network. So that means any of you don't just have to run a server to participate in Saturn. You can download Station, run it on your laptop or desktop, can contribute to the network and earn Filecoin too. And then we want to marry the two together, where L1 nodes will cache miss to L2s. And then kind of quarter 3 of 2023, that's when we want to have the public launch of L2 nodes where anyone can go download that. And that's when we want to have the kind of final connection from L2s to storage providers. So end to end, from the client to the L1 to the L2 to storage providers, is one succinct loop. So thanks so much.